Dear students, today we are going to discuss few problems related with the sections of solids. In this first problem, we can read like this: a pentagonal prism 30 mm base side and 50 mm axis is standing on horizontal plane in its base, whose one side is perpendicular to vertical plane. It is cut by a section plane 45° inclined to HP through midpoint of passing through the midpoint of the axis. Draw the front view, sectional top view, sectional side view. Also draw the true shape of section. So here the care should be taken while drawing the plan of the solid in such a way that the base whose one side is perpendicular to VP. So first of all, we start from XY line as usual. Now the pentagon should be drawn in such a way that one side should be perpendicular to VP, one perpendicular to XY line in this case. Now you can finish the pentagon like this. Then obviously the elevation should be drawn. The elevation should be drawn like this. Then depending upon the given data, we have to locate the section plane. Section plane is inclined at 45° to horizontal plane. So section plane will be inclined at 45° to XY line like this. And the other condition given is it is passing through the midpoint of the axis. So this is the axis of the prism. It is passing through the midpoint of the axis. So you have to draw a line which passing through the midpoint of this vertical axis of the prism and making an angle 45° with the XY line or HP. So our cutting plane will be like this. The cutting plane will be represented by chain line. Okay. Now the intersecting point of this cutting plane with the solid are marked as A dash, B dash, C dash, D dash, E dash as shown in figure. Now this vertical edges are intersecting with the cutting plane at point A dash, B dash, C dash, D dash and E dash. Okay. Now you are asked to draw the side view also. The sectional side view also you are asked to draw. So 45° inclined line like this you can mark and project the horizontal projectors can be drawn from the plan like this. Then from this intersecting point you can draw the vertical line. Then you can draw the height of the elevation can be marked here and the respective sides we can mark here. Now the intersecting points A dash, B dash, C dash, D dash and E dash should be copied to the side view. The side view is obtained while the observer is looking from left side. So here we are drawing the left side view which is to be drawn on right side of the elevation and the position of the observer is here, that is left side of the solid. So an observer looking from this side can see this sectioned surface. This top portion can be removed. We are assuming that the imaginary cutting plane cuts the solid like this and this top portion is removed. Okay. Now we have to draw the horizontal projection lines like this, parallel lines like this and get these intersecting points in the elevation. Okay. Now we can mark A double dash, B double dash, C double dash, D double dash and E double dash in the corresponding sides. Okay. Now we can see the surface of this prism are flat surfaces. These flat surfaces are cut by a imaginary cutting plane. So the resulting edges will be straight edges. So we can join A double dash, B double dash, say by using straight lines. So we will get a sectioned surface like this. Remember, the sectioned side view and top view are drawn in such a way that a part of the solid is removed. Okay, but the elevation will not be affected in this case. The elevation is not affected by the sectioning process, but the plan and elevation are plan and side view are drawn assuming a part of it is removed. So here we can see, then only we can see the details, inner details of this solid after sectioning. Okay, now we can finish the remaining sides by using thick lines like this. The bottom portion only remaining there and the top portion is assumed to be removed. Okay, now the hidden edges can be represented by dotted lines. Now we can finish the sectioning process by hatching the sectioned surface. Similarly, this top portion is removed and the observer looking from the top can see the apparent surface here. Here we can hatch the sectioned surface A, B, C, D, E like this. Okay. Now the next part of your question is that to draw the true shape of section. How we can draw the true shape of section? For drawing the true shape of section, we have to draw the line parallel to this cutting plane. This line parallel to this cutting plane can be named as x1, y1, and at any convenient distance you can draw that one. Okay, now you can draw the projections from this intersecting points A dash, B dash, C dash, D dash and E dash. So the perpendicular 90-degree lines from this A dash, B dash, C dash, D dash and E dash are drawn to this x1, y1 line which is parallel to the cutting plane. Okay, now mark the distance of these points. This A, B, C, D, E are A, B, C, D and E are the shape, enclosed shape of section. So this point should be marked here. So this line is corresponding to point A in the plan. Okay, so mark the distance of this point A, that is the sectioned part, from the top view, from the plan, not from side view. From plan, you can mark this distance of point A from XY line. That is our reference plane. Okay, now this will be the distance of A. This distance, the distance of A, point A from XY line should be marked from this X1, Y1. Now we will get the point A here. Similarly, point E can be located on this line and mark this distance. This distance of E from XY line should be copied to here. Similarly, this distance of B from XY line can be marked here, and then you can mark point D like this because point D is on this line. You can copy this distance of D from x1, y1 and C, the distance of C, point C from x1, xy line is copied from x1, y1. Now we will get the point A, B, C, D and E like this. Mark these points A, B, C, D and E, then you can use straight line to join these points A, B, C, D like this. Okay. Now you can hatch the inside surface of this true shape. This is the required true shape, and then you can name it as true shape of session. Okay. This is the procedure for drawing, getting the solution of for problems like this. Okay. Now we move on to another problem, which is a cone 50 millimeter base diameter and 70 millimeter axis standing on its base on HP horizontal plane. It is cut by a section plane 45-degree inclined to horizontal plane through base end and end generator. For a section plane 45-degree inclined to horizontal plane through the base end of end generator. Draw the projections, sectional views and true shape of session. See how we can solve this one. Here our solid is a cone. So first of all, draw the plan and elevation of the cone like this. As far as this cone is considered, the surrounding surface is represented by generators. Okay, so these generators can be named as A, B, C, D, E, F and G for our convenience. Okay, now the corresponding generators can be marked in the elevation also. These base points A, B, C, D are the base points of these generators, and the apex is O dash. Okay. Now the side view, we can draw the side view like this at a convenient distance away from elevation. You can draw, and now again we have to locate the corresponding points. See here G is the topmost point. So when we are drawing this side view, that is 45-degree inclined line, and projecting this point to that line and projecting in upward, we can see G dash will be this point, and the right end we can get the C double dash. Okay. Likewise, we are naming the points as we discussed while solving the problems in projection of solids. Now the projection of this particular cone with a required dimension, having required dimension, is projected, and now we have to locate the cutting plane like this. The position of cutting plane is given in the question in such a way that it cuts a section plane 45-degree inclined to HP. This inclination will be 45-degree, and it passing through the base end of the end generator. Base end of the end generator, that is passing through point A dash. Okay. Now we can get the intersecting point with these generators, and this intersecting points can be identified by drawing these generators. For that purpose we already named these generators, and these intersecting points can be projected downward. One thing you have to remember while projecting these type of solids, we can say the intersecting points will be obtained in the plan like this, the corresponding points. Okay, by naming this particular project by naming this surrounding radial lines, we can get this intersecting points on the respective radial lines like this. Okay, now this point, the projection of this point is very important. Here at the axis, the intersecting point at the axis, we can get this point by directly projecting to the true length line. draw horizontal line through this intersecting point and the axis and get the intersecting point on the true length line. As far as this cone is considered, this outermost line which represents the outermost surface is the true dimension. Okay, so the outermost generator represents the true dimension. So we have to project it into that true length side, and now you can project it downward and you will get this horizontal distance. This distance can be marked in the top and bottom directions for getting the respective points which the cutting plane intersects with this particular generators on the two sides, that is front and back. So the generators OG and OC getting intersected with this cutting plane at a distance which is equal to this distance. Okay, now we can get these 2 points on up and down of this horizontal line. Now we have to project these points, these intersecting points, to the side view by drawing horizontal lines like this and get this corresponding intersecting points one by one. Or it is a symmetrical shape in both sides. So once you get the intersecting point on one side, you can copy that same distance on the other side also. Okay, now this intersecting point between this horizontal and vertical generators can be obtained like this. Now one thing you have to remember is that in the previous problem we joined these points by using straight lines because the cutting plane cuts the solid in plane surfaces. The intersecting surface is plane surface in the previous problem because it was a prism. Here it is a cone and the intersecting surface is a curved surface. So the points obtained will also be connected by using curve. Okay, now this obtained point, similarly we will get the intersecting points on the plan by drawing the vertical projectors in the downward direction. We will get the intersecting points on this OB, OA, A dash. This is the intersecting point in the elevation. Corresponding point will be at point A in the plan. Similarly, the cutting plane intersects with the O dash B dash line at this height, and this intersecting point can be obtained in the plan by drawing the vertical projector from this intersecting point in the downward direction and intersecting at the radial line OB, this line OB. So this point is obtained. Then the intersecting point at O dash C dash and O dash G dash, front and back generators, can be obtained by the previous procedure like this, and these points, the intersecting points on the radial lines OF and OD can be directly obtained by drawing the vertical projector like this. Intersecting points can be drawn. Then the intersecting point of this plane at O dash E dash also can be projected downward and getting the intersecting point at OE. This center point is O. Now we can join all these lines by using a curve. Then we will get the surfaces, sectioned surfaces like this in the plan and side view. Now we can hatch that one by using 45-degree inclined lines and finish the drawing. Now in the question we can see the true shape is also asked. So see, similar to the previous problem, we can draw a line which is parallel to this cutting plane at a convenient distance and mark that one as x1, y1. To this particular x1, y1 line, we can draw the projectors, perpendicular projectors from this intersecting points like this. Now, the distance of these corresponding points from plan is to be copied. So, this distance of points of sectioned surface from top view can be copied to this x1, y1 line like this. So, for example, here we can see point A is this much distance away from the xy line. So, copy this distance, take this distance and mark it on this line to get the particular point A. Similarly, this point can be copied to here. This point B and H can be copied on this line, and this point G can be copied from here. Similarly, you will get these points like this. Now we can join all these points together. This will be the true shape of section. That is, an observer, if an observer looking parallel to this plane, cutting plane, he can see a surface like this. Now you can hatch the surface by using 45-degree inclined lines. Okay, listen. Now we move on to the next problem. See, problem number 3. A cone 40 millimeter diameter and 60 millimeter axis is resting on one generator on horizontal plane, which is lying on horizontal plane parallel to VP. Draw its projections. It is cut by a horizontal section plane through its base center. Draw sectional top view of the remaining part of cone. See, now again the solid is a cone, 40 millimeter diameter and 50 millimeter axis. So the plan and elevation we can draw by using the given dimensions as shown in the figure. Now the solid is resting or laying on one of its generators. The surrounding surface is composed of generators, I already mentioned. So this generators here we named as A, B, C, D, E, F, G, H connected with O. So AO is one generator, BO is another generator, CO is another generator, like that. So here in this problem, this solid is lying on one of its generators on horizontal plane. So you have to change the position of this solid. So change the position of this solid in such a way that it is laying on HP. So the elevation is copied in the changed position in such a way that it is laying on one of the generators. So we are assumed to be the solid is resting on the generator O dash E dash. So the point A dash will be the topmost point. This will be the point O dash and this will be the point E dash. Now now we have to locate the cutting plane. The imaginary cutting plane cuts the solid which is passing through its base center. Base of the solid is this one. It is passing through the base center and parallel to VP. Now we can see the plan of the solid we can draw by drawing the vertical projectors from the second elevation and first plan. We are drawing the horizontal projectors from the first plan and vertical projectors from the second elevation. Now we can see the observer can see this second plan when he is looking from the top. So an observer looking from the top can see this base circle. So it will be in the continuous thick line. So mark this base as visible like this. Now the cutting plane, which is already mentioned that it is passing through the center of the base and it is parallel to VP. See, here we can see this solid is sectioned by a cutting plane which is horizontal, cut by a horizontal section plane, which is passing through center of the base. So center of the base and horizontal cutting plane we have to draw on the elevation of the solid. And here now the intersecting point of this cutting plane with the surrounding generators we have to locate. For that, the intersecting points can be dropped down to the second plan and get the corresponding points like this. Intersecting points can be marked directly. By directly drawing the vertical projectors, we will get the intersecting point and join all these points by using smooth curve. Because the intersecting surface is a curved surface. Because the solid is a cone in this case. So the points are connected by using smooth curve and we will get the section surface like this. Okay, now you can hatch the sectioned surface like this and you can mark sectional top view, elevation, then draw the sectional top view of the remaining part of the cone is asked to draw. So we got the sectioned surface in the plan, top view of the solid. Okay, now how we can draw the true shape of the section? True shape here in this case, the obtained shape is the true shape because the cutting plane is parallel to horizontal plane and the observer looking from the top can see the true shape of the section. Okay. Now we move on to the next problem. Okay, students, now we can move on to the next problem. A hexagonal prism, 30 mm base side and 55 mm axis is lying on HP on its rectangular face with axis parallel to VP. It is cut by a section plane normal to HP and 30-degree inclined to VP, bisecting the axis. You are asked to draw these sectional views and true shape of section. Now we can look into the solution part. Here the solid is a hexagonal prism, 30 mm base side and 55 mm axis. The dimensions of this hexagonal prism is given and the position is that the axis, the length of axis is given, and the solid is lying on HP on its rectangular face. So by first we draw this position of this simple solid in simple position, then change the position of the solid in such a way that it is resting on one of its rectangular face on horizontal plane. An axis parallel to vertical plane. So first of all, you have to draw the plan and elevation. In such a, while drawing this plan, we have to keep in mind that the solid is resting on one of the rectangular face on horizontal plane. So that rectangular face, so one side should be perpendicular to XY line or vertical plane while drawing the plan of the solid. So keeping one side perpendicular to XY line, you have to draw this hexagon like this, which represents the plan of the solid. Now you have to name the corners as A, B, C, D, E, F, G, and then you have to draw the elevation of the hexagonal prism. Now change the position of the solid, that is laying the solid on this rectangular surface containing E and D. That is, redraw this elevation, change the position of this elevation like this. Now you have to mark the axis and copy this A dash, B dash, C dash, D dash like this. While keeping, you can see E dash, D dash will be on the horizontal plane. Similarly, draw the vertical projectors and from the second elevation and horizontal projectors from first plan. You will get the new plan, that is the second plan. Now we got the required position of the solid, which is resting on one of the rectangular faces. Now we have to locate the cutting plane. The cutting plane cuts the solid at 30-degree inclined to vertical plane and bisecting the axis. So you have to mark the axis by using chain line and mark the point, midpoint of the axis. Bisecting the axis means the axis, the intersecting point is the midpoint of the axis. So mark the midpoint, middle point of the axis, and cutting plane having 30-degree inclined line is drawn, which is passing through the midpoint like this. So this is the 30-degree inclined cutting plane. If the cutting plane is inclined to vertical plane, we can say that as auxiliary vertical plane, AVP. 30-degree inclined to vertical plane, which is passing through the midpoint of the axis is drawn by drawing chain line. So now what is the next step? We have to name these intersecting points. So here I am marking it as 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8 like this. And now we mark the cutting point, intersecting points as 1, 2, 3, 4, 5, 6 and 7, 8 on the plan. The corresponding points in the elevation we need to mark. For that, what we have to do is we have to draw the vertical projectors from this plan and get the intersecting points in the elevation. So draw the vertical projectors from 4 and 7. You can get this intersecting points on A dash, B dash and D dash, E dash like this. Now we have this point 1, 2 and 5, 6 which are intersecting point of this cutting plane with the top and bottom surfaces of this hexagonal prism. So for getting this distance, we have to project this intersecting point to the first plane. So draw the horizontal projectors like this to the first plane from point 1 and 2 and 5 and 6. Get these intersecting points in the first plane. Draw the vertical projectors from this intersecting points and get the corresponding points in the elevation. So this distance, now we got this distance, you can mark this distance from point F dash. Here the point F dash is this one. From F dash you can mark this distance on both sides from here. Now you will get this lines by marking this distance from F dash on both sides. You can get this intersecting points. So 1, 2, 3, 4, 5, 6 and 7, 8. Now we got all these points, all these intersecting points. Now we know the cutting plane intersects the solid with flat surfaces. So the line used for joining these points will be straight lines. So join these points 1, 2, 3, 4, 5, 6, 7, 8 by using straight lines. Okay, like this. Now we will get the sectioned surface, hatched the surface, and now you are asked to draw the true shape of section. We know for drawing the true shape of section, a parallel line is drawn which is parallel to the cutting plane. So a line is drawn which is parallel to the cutting plane and it is named as x1, y1. And the vertical projectors are drawn from these intersecting points 1, 2, 3, 4, 5, 6, 7, 8 like this. Now we know how to mark these points in the true shape. So the true shape can be obtained by marking the distance of this point 1, 2, 3, 4, 5, 6, 7, 8 from this x1, y1 line. So the distance should be marked from here. The distance of 1 is copied from this here xy line. This is the distance of point 1. We can copy this distance and mark it here. Similarly, point 2, the distance of point 2 from xy line is copied. Point 8 is on xy line itself, so it is marked here on x1, y1, and point 3 this much distance away. So copy this distance, mark it along this line. Similarly, we will get this point 7 is on xy line, so copy mark it on xy line, x1, y1 line. Similarly, we will get all these points and joining by using straight line 1, 2, 3, 4, 5, 6, 7, 8. By joining this by using straight line, we will get the required true shape of the surface. Then hatch the surface and finish the drawing. Print sectional front view, true shape of sections. Like this you have to print on the drawing.